No, I think we are.
So Josh excused himself. He's not feeling very well. So yeah. Otherwise, we're all here.
Feel better, Josh.
He's watching.
Yeah.
Oh, he promised.
Maybe he's going to watch.
No, I sent him a direct link. So.
Okay, guys. So let's start. So we have a guest here. It's Olafur, working at the center, and he'll be giving some updates on the macro front, because that's going to be the main topic of this meeting, right? So we're going to start first with the SIP C34, which is the one we decided to vote on today. And this SIP was pretty uncontroversial. I remember that Adrian Moores was the reviewer of it. So I don't think really that there is a lot to discuss about this one. Just to remind you, this is the SIP about changing the right associativity of the operators. So
I mean, not really changing the binary treatments of right associative operators.
Exactly, that's the full title. Thank you. So unless someone has anything to say or anything to comment on, we can proceed to the voting.
We didn't have comments from
we didn't.
No.
So I think it's very clear that we should vote now. So is there someone in this meeting that does not want this proposal to be approved?
Do it the right way.
Yeah.
Okay.
Let's vote.
Okay. I was optimizing for the. Okay. So is there like?
Not approved.
Raise your hand. Raise your hand if you want this proposal to be approved.
I raised my hand.
Okay. Okay.
If you raise your hand with the camera off, did it really happen?
Okay, so it's been approved by unanimity. Okay, so then we move on to the second item in the agenda. This is path types. So we had lots of feedback from the community and also from the committee members, and we are working right now on the updates. We don't have them ready yet. So Eric has done some nice progress updating the motivation and the motivation section and the examples of why path types are useful, aside from just using value classes in Scala. And I'll be writing up some details on some technical details, comparing them to value types in the JVM, and based on the last specification that John Rhodes wrote. And we'll be discussing that in more detail in the next meeting. So we would prefer to review those updates in the next meeting because they are not ready. And we will also present some implementation details. So as there's nothing to discuss here, unless someone here wants to discuss something concrete, I think we should move to the third item. Yeah. So the third item is match infix and prefix type. So I don't remember right now the full title of this proposal, but it was created by Oron Port, and we got a PR. So there is an official implementation of this in Scala. Do you know something about this, Adrian? Do you get some time to?
I saw the pull request yesterday. Yeah, I haven't had a chance to really look at it since I just got back from a week of meetings.
Yeah, it's 3. Yeah.
So, I mean, I think last time we talked about this SIP, we actually wanted some more motivation and some more clarity. I haven't really followed up there, so I can't really comment more than that recollection.
I don't remember that, but I can ask Oran for details on that.
Okay, maybe I'm misremembering. That's very possible.
So I think that the way we should proceed here is I think we all agree that this is an improvement over the status quo. So I think that's what the best way to proceed is just to review the PR and come up with some implementation comments. And then when that's passing, we can basically vote on the proposal or ask for more refinements. What do you think about this, Adrian?
Yeah, I'll let mine go first. I was just refreshing my memory of the SIP, but.
So the proposal has two parts that I can see. One is to have the same rules for infix types, for precedence for types and expressions.
Yeah.
And the other is to introduce prefix types.
The prefix types part was meant to be split. So I think that Oron's goal was to put them together because he thought that they were closely related.
Yeah.
And last time we discussed this, we kind of agreed that they're kind of like orthogonal, so we should discuss them separately.
Okay.
Because right now, I think he has provided an implementation for not for prefix type, but for the associativity of infix type.
Yeah.
So he's matching the associativity of infix types in types to terms.
Yeah. And as I understand, Gotti already does the same thing.
Does it? Okay.
For prefix types, I'm much more skeptical about that one because I think sort of prefix expressions are not a feature. They're sort of just a necessary compromise to standard mathematical conventions, so they have to do it, but it's a sort of a word on the expressions. So to generalize that to the types, I don't see that much motivation really. Whereas, of course, once we fix rules for associativity, then to have types and terms be the same, that seems more natural.
Yep.
So I would say tentatively yes for the infix part and no for the prefix part from my side.
Agreed.
Any other comments? Yeah, I cannot really comment on prefix types. I don't have anything to say. Do you have something to add?
Nothing to add to what he says.
Okay, so we'll ask, what I will do is to ask Oron to give a better motivation for prefix types, and then we revisit that in the next meeting, and we try to come up with some concrete details of what he wants or why he wants this feature, and then if the motivation is not good enough, then I think we can vote on this.
I would suggest we make 2 SIPs out of this. I think in general, one idea, 1 SIP, and since these aren't really, that related. I mean, they're related in some sense, but they don't depend on each other. I would just ask him to start by splitting up the SIP.
Yep. Okay. So that's probably the best way to move forward. Perfect. So.
I mean, is there kind of any hope from the committee that the other one?
Well, I think it depends on the motivation, right? So if Oron is able to provide a good motivation for prefix types and business types, well, of course, something that we should revisit.
There is always a motivation section in the current.
Yeah, I think that's a really good point, and to be fair to him, we should make it clear that we're pretty skeptical about the second part, and that might be hard to convince.
Double up and try to convince us, or close it if he doesn't feel strongly about it for this part.
Yeah. So definitely what we want to see is an independent SIP or strip down this one to just talking about the associativity of infix types, and then whether or not he wants to set up a second SIP about the prefix types, bearing in mind that we are more skeptical about it to begin with. So that would have to be more motivated, and also it might, I mean, there is a significant likelihood that it would be rejected.
Yeah, I think he was aware of this when last time I talked to him. He told me that he would expect some more problems with that part of the proposal. So, and he told me that he wouldn't have any problem to do it. So I will just discuss it with him. In private. Perfect.
But yeah, as a general rule for the committee, I think I really like that Sebastian brought this up. We should be respectful of everybody's time, and if we feel like there's almost no amount of refining you could do for us to accept this, we should be very clear about that.
Yeah. The reason I asked for a better motivation is because I don't see any good motivation for prefix types in the current proposal. So yeah, we expect a better and longer motivation just for this feature. Okay, but I completely agree with you, Adrian. So let's move on now to the hot topic of this meeting. The hot topic is macros, so we want to know a little bit about the current efforts towards improving the macro system in Scala. So Olaf has been working, is working right now on this, along with other people at the lab, Fonview from the OT side.
I will give it an update.
Yeah, and he will basically now provide more details on this.
Can I just jump in real quick for a second?
Yeah.
So just to maybe give like one step of context. So Olaf is not going to be presenting like, hey, this is the new macro system and we've already implemented it or something. I think that, you know, structurally the idea going forward for the next few months is to just give regular updates during the SIP meeting so that the different sort of teams know what the heck is going on and who's focusing on what and kind of what the design issues are at the moment. And if there's suggestions like, hey, that'll never work, you know, perhaps the SIP committee could weigh in and inform us if something is completely crazy. So just, you know, to establish like this is not anything that Olaf is going to present is mostly just like, you know, a current data point in the design space. And I think we're going to end up doing this for a couple of months before we have a good SIP that we're all kind of confident about that we can really start voting on. So
I think that's a successful discussion with, or like, we consider this as a successful discussion if we end up knowing well all the trade-off, all the design space, and also all the complexity that is around this topic, and we kind of like exchange different interests because I think that we all have different interests here and we all want to see different things. So it's good that we try to come up with common points of interest and we move forward from there. So Olaf, if you don't mind, can you go forward and explain a little bit about what you prepare to present?
Sure. So yeah, you can comment. If someone wants to follow along what I'm saying, there's a small gist that I just wrote that sort of I want to go through, but you can also just listen to me say. But the last SIP meeting ended with the conclusion that that this proposal from the Scala Center proposal had been approved, and that I would lead the project and gather a team and then share updates at the next SIP meeting. So I'm happy to say that we have a pretty great team. I've been working closely with Liu Fengyong, who's part of the Doddy team, and then Mikhail Mutsianko from JetBrains on the IntelliJ Scala team as well is collaborating with us. So all of us are sort of tasks. We have
It's not much, but it's just sort of what I will go through.
Excuse me?
It's mostly just bullets.
Hi.
Hello. Hello.
Hello. Can you hear me?
Yes.
All right. So and then we've had several meetings.
I sent you on Slack.
The other
You
video
don't have to put it in now.
I think it's the YouTube. Yeah. So there we go. All right. I apologize. We had some echo. We've had also we've consulted with quite many people and had several meetings discussing, figuring out what the current issues are and etc. So had meetings with the Scala compiler team at Lightband. Ryan Culpepper has worked on Racket macros, so it's really nice to get input from their side of the view. And then also as well, Eugene Bermacco, of course, is consulting us a lot. And we initiated some discussions on the contributors forum to see what people think, in particular with regards to white box and black box. So, but my personal role, the way I see it, is to communicate with the involved parties. I think we are researching what is the ecosystem, what is the landscape, what are the main problems, what are the trade-offs, because I believe that there hasn't, first we need to figure that out before we start writing or claiming a new macro system that solves everyone's problems. And then as well to coordinate some engineering effort to write this new macro system so that it in fact actually addresses some pain points, and as well that we can deliver something at least useful within the next 4 to 6 months, I would like to see, since my personal, or like the Scala Center's investment in this project, at least from my side, of course someone else could take over, or I don't know, but I think we should aim to have something deliverable at least in the next few months. And then for what I would like to get out of this particular meeting right now is to sort of present the main findings that I've found to be interesting for the past 3 weeks, present my personal recommendations, and then maybe hear what you think. So I don't really have any comments on SIP 29 besides that the proposal on META, besides the fact that I'm a bit concerned with the scoping changes by unification of macro definition and implementation. And I believe that the current system in Scala Reflect, by separating macro definitions and implementations, is a more robust design that doesn't require changing rules scoping, which I think is a big plus. It also addresses a bunch of problems, some problems such as how do you pass in type parameters from enclosing classes. It's not really handled in the SIP 29 META proposal. So this is what me and Fong Yung discovered. But I want to primarily focus on the one observation we have been categorizing roughly what features macros need from the macro system. And I think that these are not white box versus black box or annotations. These are actually what they need to work. And they are related to, I'd classify them into the transformation macros, as in they can inspect the trees and they can construct trees. Then you have these generation macros that can only generate trees, they can only construct trees, but they cannot inspect trees from the compiler. And then you have inline kind of macros in Scala Reflect today, and these are examples such as log4s. These are done for purely performance reasons, so that you can avoid a method call, or constructing some expensive strings, etc. And then I also just recently found out that there's also this category of linter macros.
Linter macros, yeah.
They
inspect but don't generate.
They can only inspect but not generate. But all of these are able to report errors, so that's what linter macros would do. And I'd say the only inline macros have a potential sort of migration path or are solvable with SIP 28. And that is still open a SIP. So I'd say the sort of big challenge here is number one, transformation macros. As we'll see, they are very tricky. And generation macros, which I personally believe are less tricky, still address quite a lot of pain points, and we could support quite quickly in a robust and a portable fashion. So I'll briefly explain. So I have here a table of a few example macros just to give you an idea. The transformation macros are like Scala async, Scala test assert, or the F interpolator. All of these need to construct trees and then, inspect trees and construct trees. Then you have these generation style macros, which are like JSON serializers. And they are able to inspect types, symbols, annotations, but not trees. And our experiments in our repo currently is that it's fairly portable and it can be quite robust to expose type information, types and symbols, both across Dotty and Scala C. Then you have macros like Scala test position. These are ad hoc compiler APIs to get the file name and the line number of the call. They could be done at runtime by throwing exceptions and catching them, but and then there are like a library called source code from Huawei, where you can request an implicit name, which essentially gives you the enclosing owner of the call site. And this is used, for example, for fastparse, the parcel combinator library. These do not need to inspect any trees, only symbols and types. So transformation macros, in my observation, are really tricky. There are many hard, open, unsolved problems. They're most notably related to how to mix unattributed and attributed trees. If you put a untyped tree under a typed tree, you can break some compiler invariants, causing cryptic crashes. If you put a typed tree under an untyped tree, then you can potentially break owner chains, corrupt owner chains, and that can cause crashes in later phases. And the techniques that people so far in Scala Reflect have been using to solve these problems are with untyped check and type check APIs. And then there are some more explorative or some working solutions to automatically repair trees. And this has been successful mostly for owner chains, for some limited macros, for example, in Scala test. But the automatically type checking sort of half type checked trees is still little explored, but might have good potential. And then another technique is to, at the type level, separate typed and untyped trees. And that you can use that for more information to do more smart automatic repair. And then one approach that Feng has been exploring a lot as well is to just provide constructors for typed trees. And macro authors then need to construct typed trees. And it's quite a different API from how to construct untyped trees. So that means that when you do a transform, you would have to return a typed tree, not an untyped tree. So the last bullet I want to make is that all of these different solutions for transformation macros have different trade-offs with regards to what features they can support, and how portable they are across the compilers, and also the breaking changes from the sort of existing macro ecosystem. Because if you say, okay, well, everyone have to construct type trees now, that's a very different API than what people are using currently. So a lot of very popular libraries are currently relying on untyped check. And converting it to a typed tree constructor API would be a significant refactoring, whereas, in my view, if we could provide if we can have a smarter untyped check, that would be a much smoother migration path for existing ecosystem. So, and then, yeah, for the generation macros, I think that they don't seem to be any major roadblockers. And that one observation that I've made that I find personally interesting for the SIP committee is that when you can only generate untyped trees, you cannot change the semantics of the language. You're essentially generating boilerplate, but you cannot take an existing expression and give it a new meaning. And personally, I find that satisfying since it's a simpler model and it's closer to the Scala language. So you're not able to give new meaning to if constructs or other syntax. So that concludes my sort of update. And I'm really curious to, like, my personal recommendation would be to prioritize generation macros. I believe we can deliver them quite quickly and robustly. But that would leave quite a lot of popular macros currently unaddressed. So I'm curious to hear what people think and what we should prioritize.
Okay. So let's just think about it.
I think there are lots of decisions to make. Do you have any concrete problem that you think should be addressed first? Or do you have any question for the community?
So I'd say
I'd like to see an answer.
A very general question on this matrix of feature support, portability, and breaking changes, where, you know, ideally we have no breaking changes and we get all the features that we currently have, or, you know, and they port across, you know, compilers. But I think personally that's a very ambitious goal that we may have to do some trade-offs. I'm curious to know what people think, what they price the most. You know, is breaking changes really bad, or is more limited macros but then more portable? Would that be a route to explore?
Well, there is another axis that I would value more, which is the new things that we do put in place and that we do provide, as soon as we do provide them, they basically are stable. Like the new things we provide from now on, we wouldn't break them anymore. Just slightly different than breaking from what we already have now in Scala Reflect or whatever. I think we should even more avoid future breaking changes than avoiding breaking changes now.
In that regard, I think generation macros can quite robustly be added without changing transformation macros. There are many open problems with different solution spaces. So that's not something you want to maybe put into everyone's hands right away.
About the generation macros, I have one question maybe, which is, so we only build n-type trees, right?
Yes.
But what about names? Like, can I at least, refer to something with, let's say I have a global constructor for a class. Can I at least instantiate that very class and not just, something that could be shadowed by the enclosing scope or whatever?
We could definitely provide some solutions to hygiene.
Because I think this is the one thing that we should
one potential solution for hygiene is to limit the constructors for untyped identifiers. So that you have to select from qualified types.
Could you elaborate on that?
So essentially, to enforce hygiene, you would have to prefix everything with root, because you can't just put in an unbound identifier. That's one solution that has been explored for hygiene. But
so either it's bound within the n-type tree itself, or it's rooted in root.
Yeah.
But the root is only for global identifiers. There might be
for global, so for local.
By others.
So question is, to generation macros, since they don't have the ability to inspect, how can they reference local identifiers?
No, local identifiers.
Hey guys,
Adrian wants to say something.
Sure.
Before we get too technical, could I suggest a different methodology for breaking down the problem and
sure, absolutely,
time and risk management? Since we already have a macro system, I would actually be more interested in simplifying things that are currently broken or suboptimal in the macros that we have right now, and spend the time there first and see how much we can improve before we go to the things that are more clear on how to progress. So I think there's a lot of interesting points in the gist about splicing trees and making sure that you end up with owner chains that are correct. And this other example of hygiene is another good one. I think we could even experiment in the current macro system with better tools for macro authors or more correctness enforcement, and then see how we can do that in the new system.
Yep. So my biggest concern with that is portability. That would it be a significant subset of the current Scala Reflect API?
Well, so this is an experiment, right? So I think what are the big unknowns about the project right now? Like where are we not sure how much time parts of it are going to take and how hard they're going to be? I think we should try to eliminate those uncertainties first, and experimenting in the current macro system is just a cheap way to do that. It doesn't necessarily have to end up in there, but I think it could inform how to implement it in the next gen system.
I can say that the repo that we have currently, we are implementing macros in terms of Scala Reflect macros.
Okay.
So the APIs that the engine uses are the macro APIs.
Right. So it shouldn't be too hard to do the experiments on the current APIs and figure out how to splice trees and how to deal with hygiene. And I don't know what the other, off the top of my head, the other challenges are really, but I think there's a lot of value in dealing with the common gotchas automatically.
So I am actually just experimenting exactly with these APIs currently, like when I'm coding. So that is what I'm doing, is using the current macro system in Scala C.
Mm-hmm. I know.
We just have a repo where we can share the same sources for macro implementations across Dotty and Scala C. That's the only.
Sure. I mean, I understand that's the goal, and eventually, I'm just talking about, since we were talking about, we're not sure how much this is going to take, how hard this is going to be. I think it's important to try to figure that out first before we do the ones that are lower hanging.
I think that's
But
as well to
that's
say.
my opinion.
I think it's important as well to set the goals and expectations of this macro system. So this will like hugely modify the roadmap for our next steps, right? So in your review, like I see that you like value a lot as well improving Scala reflection. I think that's something that has to be done. But I think that also,
No, that's not what I said. I meant to say take the more ambitious features and experiment in whatever vehicle we have right now to do it. If it doesn't land in Scala Reflect, that's fine with me. But I would just caution against doing the easy things first. I think we should do the hard things first.
yeah.
And they can land in the next gen system. I'm not saying you have to implement all of this as a production system in the current one. But I just suggest implementing because I know that the current engine is implemented on top of what we have already.
Okay.
One comment that I have.
Prioritize the really hard problems.
I think Eugene is really
I'll leave it to you.
eager.
Okay.
So something that I want to add what Adrian was saying is that Scala Reflect API is significantly bigger than what Olaf has in the prototype. As a result, this may complicate the experiments. For instance, one of the approaches to fixing owner chains was separating typed and non-typed trees and signatures. So this kind of changes, it's a fundamental departure from how Scala Reflect is implemented. So maybe that would be more complicated to experiment there. However, I would kind of side with Adrian, so I'll be ambivalent. Some of the hacks that Jason proposed a couple of years ago, like the macro splice macro or whatever it was called, the automatic owner chain fixer, they can be prototyped in the current macro system. So yeah, it's really both sides. Though I want to say that I agree with Olaf that the classification of macros is actually useful. The transformation generation and so on and so forth that Olaf brought up in the gist. So indeed, if you want to support just the generation macros, maybe it wouldn't be that hard. So yeah, but then the question would be how valuable transformation macros are to us as the community. I mean,
why is generating type macros from the start? So you mentioned it was a significant departure from current things. Can you elaborate on that? Why you find that difficult?
Just looking from trying to transfer the existing macros that do anti check to refactor them into use typed reconstructors is a large refactoring.
Is it?
From my personal experience with the microtest tracer macro, it wasn't quite a change.
So what did you have to change?
In that case, he expands like an idep into a block.
Yeah.
And then, so you have a layer of typed, untyped, typed, untyped, and you're in the untyped block referencing an identifier that you introduce at the root. And if you even do type check on the block you expand, you're gonna get an unbound reference to above. So that means sort of changing the top layer to get maybe it's possible. I think personally that's a promising avenue to explore for portable macros.
From my perspective from Dotti, where essentially every transformation phase only goes type to type, and we never had any problem with that. So there was nothing ever that, and it's exactly the same interface. So essentially you import from untpd or from tpd, but everybody imports from tpd, and that's what they all do. So that's why I wouldn't disregard that yet. I think that's will ultimately be the much easier API. So in particular, so the other difference is essentially how much type checking magic should be done on macro generated code. So right now, essentially you generate untyped trees and run the typer on those untyped trees. That, in my opinion, is an extremely fragile way to do things. I mean, the typer is an incredibly complex machine implementing all sorts of rules of Scala. And essentially, as a macro author, you just You just have confidence that this will work for your code blindly, whatever the input arguments are and things like that. So I think this is, I would be very nervous as a macro author if I had to target that platform. Whereas if you have, what you have in Dotty is essentially this super simple type assigner, which is just a couple hundred lines, which essentially you have to spell everything out for it. It doesn't do any magic conversions or anything, so the types, everything has to be implicit. But then it's very predictable what it does, because everything has to be implicit. And in my experience, compiler writers prefer rather a brain-dead simple platform than a platform that itself does a lot of magic, because magic breeds fragility, basically. If you rely on magic, you think you don't even know you rely on magic, but you do rely on magic, and the next input that the user provides breaks the magic, and there you have your failure. So I would very much encourage
to make
to pursue this, to say let's have the simplest brain-dead, most safe platform that we have for writing these macros.
Can I ask a question then? So to make your, I mean, I think I understand what you're going for, but concretely, what does that mean? Does that mean like getting rid of quasi-quotes or something, or because this is the untyped trees that you're splicing together, right? And, Olaf, you and I were discussing this yesterday about how magical they can be, and everybody relies very heavily on writing macros using quasi-quotes, but I'm not sure concretely how your suggestion can be realized.
Well, even for that, you could have quasi-quotes that only use the very simple type assigner, so it parses it type checks, but it doesn't do anything like inserting implicit conversions or inserting dot applies or turning into updates.
No. So before we even get into that kind of stuff, there's the general pattern that people have a tendency to write like, I don't know, like 6 different quasi-quotes, and they splice them all back, together. Like that's how people write macros, and it makes sense if they're all untyped, and then you type check them later. So, I mean, I guess you would lose the ability to write code like that. Forget about, the more interesting things that they can do.
So yeah. So okay, but for the quasi-quotes, I think so. Of course, we want to keep quasi-quotes. The question is, if a quasi-quote refers to free variables by identifiers, should that somehow be reflected in the type of the quasi-quote? So one possible design would be any free variable that you refer to, you have to essentially put in the type, that it becomes basically a function type from essentially I mean, higher order abstract syntax is a very similar way to deal with these things. So that would be a way sort of to say to have types all the way down. The alternative would be to say, no, we actually quasi-quotes can refer to free variables, and then they wouldn't be typed. But then I would say it's really important to distinguish in the types, because a quasi-quote that has free variables and can refer to anything is quite a different beast from a quasi-quote that is closed and that has a well-defined type and things like that. So I think we definitely want to distinguish between the two in the types. Or maybe drop the untyped version and systematically type abstract over everything that a quasi-quote refers to. I'm not sure that's feasible, and I'm not that much into it.
I think one observation on the typed constructors, it seems simple for valdefs, functions, blocks, but the constructors are a bit more tricky for member definitions. In new anonymous classes, then it gets a bit bigger, but I guess less magic, but you still have, and then you need to have a constructor interface that is portable across both for Scala.
Yeah.
So those are some problems.
But I think that actually will be,
solid.
I mean, that will actually help portability a lot. Because essentially, I think that sort of where Scala C and Dotty will first be joined at the hip is on the level of basically tasty trees and the type trees, and that's essentially the level of types that are also proposed as essentially the macro format. So that's, I think that will actually help, because that's something that Scala C and Dotty can very easily agree on at these sort of low level type trees.
Maybe if no one has a comment, I have one sort of request. I feel in these discussions that I'm a bit not maybe too knowledgeable about Scala C compiler internals to answer some questions. And I would be very much appreciate having a bit more help on that front, actually. Because currently it's Fong prototypes very rapidly things in Dori, and then I feel that I'm a bit slow. So even if I have
everyone is slow, except some gurus.
So, but anyways, that was just a remark.
So one thing that would really help if for Scala C infrastructure, which if Scala C had something corresponding to .NET TPD and type designer, essentially a simple, super lightweight way to construct type trees, which Scala C lacks right now. You have to run the full typer on.
Isn't it the typing transformer? How different is it from the typing transformer API? Eugene can
local typer. And it can do everything.
It runs the full typer.
Yeah, I think so.
Maybe answer that from. I think that was the route that Eugene was encouraging me to explore, how to have more sophisticated typing transformers.
I mean, I would love to have the type assignment from Dotty Porta to Scala C. I have to think a bit on how we can help there because we have a pretty full schedule to get 213 out. But I do second that idea.
What type and transform API does? This is the part of the internals of the context, c.internal. It basically traverses the tree, remembers the owners, and then it gives you an API to do type check if you'd like at the current owner. So it does not do type checking per se. What it's useful for is taking a type tree and then inserting untyped parts there, type checking them on the fly. So it's a bit different.
Okay.
And well, speaking of ways to create type trees in Scala Reflect, there's just one really. So you create untyped trees and then you assign symbols and types there. Nothing like type assigner. So it would be useful to have a type assigner indeed.
I mean, if you do it by hand, it's incredibly cumbersome and nobody can seriously propose that. So essentially, for Scala C, currently the only way is really to run the typer on an untyped tree, the full type. But the full typer is sort of, it's A, very expensive, and B, because it comes with all the bells and whistles, it also can do lots of magic with it. Don't even want.
Yeah, so indeed, I would not propose this API for macro users. The fact that people have to deal with it right now, it's regrettable.
Can we build a type assigner API on top of the existing Scala C symbols, types, trees, blah, blah? Sounds like we should be able to do that.
Yeah, why not?
Yeah, it's just a matter of time.
If we do that,
Yeah.
so like this type assigner would be essentially very dumb, right? How would this interact with macros that make a heavy use of implicit search? Or like it's clear that macro users would be required to have to write their code, their macro code, more explicitly and maybe very low level Scala code. But implicit searches is basically a fundamental mechanism of the current macro system. How could you
have to run search explicitly?
Okay.
But how do you set up the context for that?
Access to typer.
The implicit search mechanism of typer, yeah.
So there will need to be some kind of separation of content between the typer and implicit search. So that would be also a quite a huge undertaking in Scala C, I think.
Yeah, possibly. So yeah, so I just wanted to maybe come back to this problem of black box and white box and
because I haven't even mentioned
it. So I think it was good that you did this orthogonal categorization, which is I think very important to say what kind of classes they are. And I think black box and white box, they are sort of also important because they are sort of the cost model what macros. So in other words, I mean, why don't we all go for the maximally powerful version of macros that essentially why even consider sort of simpler variants. And I think that there are essentially two costs. One is the tooling, and the second is the language fragmentation, basically. If a macro can redefine a lot of the language, then it leads to language fragmentation. We might not want that. But I want to concentrate on tooling now. So tooling, the issue is that essentially macro code, full macro code is arbitrary user-defined code that can do lots of things that can take lots of times. And I guess our experience is it does lots of weird things, and it often does take lots of time. So we have learned that that's the case. So so the question then is when to incur that, and there's sort of a succession of things. So one would be to say the current white box model sort of forces you to incur that cost on every time you change anything in your IDE, because that's when the type comes. And to do full completion, that's what happens. Black box macros incur the cost. That's interesting that in principle, not in the IDE. So because you can type check without running this thing. And in the build, they incur it either during typer or after typer, depending on when they run. So if they run after typer, then we have to do something with implicit search to provide implicit search after typer, which is sort of not quite clear yet how to do it. So that's now a question. Essentially, what? So the most liberal one would be have white box and black box. So the next one would be, and then do something with the types. I'm not sure yet what. And the strictest one would be basically inlining only, and the rest would have to be done with a special version of Scala somehow. So sort of like template Haskell. Sorry?
That's probably a bit extreme at this point where the ecosystem is.
Yeah, I'm not sure. I'm not sure. It might be, but it might be that we're forced to do that. So the thing to have essentially a template Scala, something like that, to support everything would be a way to get the ecosystem over, and at the same time to distance ourselves from. So to say, okay, if you do that, then it's template Scala. It's no longer full Scala, classic Scala.
One thing about Scala template or template Scala is that you could provide different implementations with different compilers at the same time as you are idiomatic in both, and that can be seen as a good thing.
Yeah. So
and with regards to white box, I think it's a bit more nuanced, because I think white box actually comes in different shades of white.
Sure.
I think most notably, it seems they're fairly, I think there's a very interesting design space for white box that don't play with implicit, as in for implicit search, they use their declared type instead of expanded type. Those would be, and for they would not have funded materialization. I think there's a very large set of white box macros that fit into this area that are very popular.
Like what?
Quasi-quotes, you have all of these.
Quasi-quote pattern matching, or which one?
Also regular ones. Well, in Meta, they narrow to the most precise type. Then other ones that are specific, they've been used for some of the refined types. And then I've seen white box. God, I should have written down, because there's actually quite a lot of white box that falls into this category from what I've seen. So I think that is maybe, I'm not going to call them gray box, but I'd say white box that are do not require funda.
An example is Spores.
Spores Quill, I think, falls into that category, which is a very popular lick, etc. And I'd say that there's a fairly large migration concern, as in there are quite many. They're very popular that are in this space. But
how do you distinguish the good ones from the problematic ones.
Well, in terms of implicit search, I would just say that it's their declared result type, and then they're essentially like.
I mean, you're going into a macro implementation. You have no control over it. I mean, for the compiler, the macro implementation is a complete black box. Excuse the pun in a different meaning. Yeah. So it does whatever. So.
No, but when it's, I mean, if I understand correctly, it's if you're about to summon an implicit and try it out, and that implicit that happens to be a macro, then you immediately throw it away if its declared type does not match what should be the declared type for that implicit to resolve.
You never have to expand.
And so you don't have to expand it in order to decide whether or not you are going to apply that implicit.
Okay. Yes.
And once you've chosen it, then you apply it, but it cannot. It cannot. I mean, it cannot fail anymore. If it fails, it fails.
Yes.
And then your code doesn't come back.
This is, in my opinion, the most hairy spot about white box, how they play with implicit search, and that they can fail without you silently fail without you knowing, and that slows down compilation without you even being aware.
Yeah, but still, I mean, you could probably make that. I don't know. Maybe. I have to.
Another simple way to specify it is that an implicit def has to be black box.
Well, in Kotlin it has to be black box anyway because implicit def neither declared result type.
Right. So basically, that's
That's about what I was proposing. Roughly, is that it behaves as a black box for implicit search.
But even if it has an explicit result type, you can override it. Right? The current macro engine overrides the explicit type.
But you could still have a white box macros which essentially uses the implicit search API to do these things. So there's ways to get around it. So
I'd say
so my main concern is essentially when do tools have to run untrusted code in the compiler? So that's sort of the cost model. How much of that are we assuming?
I think that is. I haven't explored it, so I'll maybe have updates next time.
Okay.
The only one other big topic that we haven't mentioned and is on the contributors forum, but that's annotation macros. I'm very concerned about even if they're not even part of the Scala compiler. I think there's a very large part of the ecosystem that relies on them. I think that, for example, Scala 2.12.4 is out, but a very small fraction of the ecosystem is able to upgrade until Paradise is out. And whether we like it or not, that's the state of affairs. And I think that that's causing language fragmentation. I think there's an ongoing effort to sort of remove Y flags and to remove fragmentation in the language. I think you should be able to take a Scala source code and run it at the compiler of the time, and it should work. But Paradise is so widely used that it's merits inclusion. But that was just one note. I think we're digressing anyway. So.
Yeah, that's a good question.
I think basically if we, I completely realize the pressure that we are under, but I think basically if that pressure, we need to yield to that pressure, then the only way I see is to have two versions of Scala, one meta Scala and one normal Scala. But that's still a possibility. I mean, my macro Paradise was sort of this sort of unofficial one. But I think what's missing from the previous one that was sort of a flaw in macros from the start is you had to essentially add all sorts of stuff to the Paradise. Paradise, you have to have a plugin at the use site, right? At the use site, yeah. So we have to say, well, this is a compiler with that plugin, then we don't call it Scala anymore, we call that meta Scala.
So the problem here is that then it's actually, because there's quite a large tooling issue with, and now we have actually two flavors of macro notations, and the lack of direction is causing problems for the ecosystem, which is in the end paid by the ecosystem.
Yeah.
So I think there's reason to actually
But for macro annotation, so what are some good use cases of macro annotation?
So the big ones that are widely used today, one of them is this simulacrum macro annotation. So there are encoding certain design patterns, and they could not be replaced with just a script that generates code because your code lives with that.
But I can kind of really state, at least for the Docker side, that's for me a complete abuse of macros, and I would say it's actually a big advantage from the Docker side that we will not. That by itself is not I can essentially create new Scala that has nothing to do with Scala, and that sort of imports and logic imports and macros. So if people want to do that for current Scala, it's too late. We can't prevent that anymore. So we probably have to go ahead. But for Docker, we will make a clean break. This will not. This sort of thing will not. I will make sure that this sort of thing will not be possible anymore.
All right. Because there's another one which is essentially, if you say like, oh, I want to derive these type classes, you can just add the annotation on the class, and it inserts the implicits in the companion object. From my personal point of view, that is not creating a new flavor of Scala.
No, that's a good one.
Encourages best practices.
What we will try is to essentially steal the best of that and put it in the base language. So,
great.
So this poses the question of how portable this macro should be, like this macro system. Because
I'm not sure if
moving things.
So that's also why I think that sort of having two languages is good to say, look, we have, let's say, meta.dotty or meta Scala 3 or whatever, where you can do these things, and we have the sort of the paradise functionality, people can play with it, and then we say, okay, for the standard Scala, we try to sort of, as soon as things have proven themselves, like the deriving macro, we try to put that in the full language and make it essentially robustly available to everyone. I think that's, for me, is a more sustainable model than a free-for-all with macro.
I think that sounds like an interesting avenue.
I think Julian wanted to say something.
You not?
Oh, you were talking to me. I just, maybe I missed it, but I would add to the list of tricky macro things that should be clarified, the interaction between type inference and macros. Because right now, I think almost every code that uses shapeless relies on the fact that when you have two type parameters, one is unbound or you have actually no constraints on it, it will be guided by shapeless to be the H list representing the other type parameter. So one is a case class and the other one is free, no bound, no constraints on that one. And actually the shapeless macro comes in and sort of guides type inference towards the H list that it represents. And I think this is, I might be mistaken, but I think that current implementation type checks 3 times the result of the expanded tree. Once with a wildcard type, another time by replacing some type variables with wildcards, and a third time just for good measure. I'm not sure why it's the third time. But so it's I think, one of the hard problems that you should probably look at.
Okay. And I think this is a great example of something that just should go into the language.
Yeah. Good. Oh yeah, the other thing I wanted to say is, so in these whole complexities to say, well, Meta can do anything, and we run untrusted code in the compiler. There's one thing where you really are completely sane, and that's the inline part of inline Meta. So inline is sort of uncontroversial because the compiler does everything, so there's no user code doing the expansions, and it has strict limits what it can do. So it won't, well, we have already seen Stack Overflows with inline as well, but sort of it's generally better behaved with these things. So if there's a way, I would still say, if there's a way to sort of split it into inline and meta like we had with 2020, what was it, 27,
28 and 29.
Yeah, 28, 29. I would say that is something that I would very much value, and I think for Docker is something we would definitely like to keep.
Keep them under the same.
Keep inline as sort of an enabler of Meta to get full macros. So essentially, the two things: inline does the job of moving code from here to there and doing some super simple simplifications.
Right.
And that's hard because of you have private accesses and this whole thing to move code from here to there is already fairly involved. And then the actual generation with quasi-quotes and the inspection, that's a job of Meta. One thing we could look at is whether maybe we want to, like you said, split generation and inspection. That's an interesting idea. If you only have generation, then we basically have a meta or
That's
meta.
And the inspiration actually came because Oleg was here. He said that people say it's not powerful, but it really is. He said that kind of stuff.
Mm-hmm. Yeah.
So I see here like two different suggestions or opposing suggestions. So I would say that Adrian's suggestion a little bit clashes with Martin's suggestion. And I think it's important that we try to finish this discussion with a clear direction or some kind of like something we all agree on that should be explored. So I would also like to know other members' opinions about the macro system. So please feel free to chime in. And I would say that to conclude, let's try to look for some kind of common goals that we all agree that Olafur and Wenjun should work on.
What should we do for the next month?
I've explored hard things, and I think a lot of the things that Martin suggested are very valuable hard things to explore. So I don't think it clashes that much what I was saying.
Well, it does, the fact that if you start improving Scala Reflect, you will start improving all these APIs, right?
So I think I probably shouldn't have positioned it that way. I just meant, experiment there because we already have it. I didn't mean you have to come up with an improved Scala Reflect.
Okay. Yeah.
I'd like to add, there's also a fairly capable macro implementation.
On my side, I would say that, well, indeed, Olaf in the gist and in the presentation mentioned that mixing typed and untyped trees is an unsolved problem. Basically, that's an area of research. And it's a good question whether we want to engage in that research or not. I understand I may be biased. I've been doing this thing for more than 5 years, right? But I think we're just a couple steps from solving that. So automatic owner chain repair, it's already been tried, thanks to Jason's trick. And we can do similar stuff to nest in untyped trees inside typed trees. We discussed that with Olaf privately, and I can provide details on the forum so that I don't waste everyone's time. So anyway, speaking of what to do next month, I think researching into those two things, nest in typed trees under untyped trees and vice versa, well, that's the hard stuff that Adrian was referring to. If we get this handled, that will help both Scala Reflect because these findings will be directly portable to Scala Reflect and the new macro system. So maybe if we convince ourselves that that's not a problem, that's not research that's solved, maybe we can support more macros in the new macro system.
Like that, more robust macros. I think a lot of current macros that are using untyped check could use this more robust system instead, which is a win.
Oh yeah, so in the ideal world, I think untyped check shouldn't exist.
So I mean, to turn this on its head, if we said, well, let's do the easy stuff now and figure out the hard stuff later, I think the chances are that we just won't do any of it because these things always take longer. So I think getting some of the hard stuff out of the way now will give us clarity on what we can actually support next year, and maybe also yield some results actually. I don't really care to the details of what exactly the hard stuff is, but answering some of the questions that were raised in the meeting, I think would be a great way to spend the next month.
Okay. So one hard question is, I think, how restrictive is it to demand all quasi-quotes to be fully typed? That means instead of a free name reference, you'd have to essentially type abstract over them. So lambda x of some type, and then splice x into the quasi-quote. So to do it like that, write it like that.
Mm-hmm.
I don't know. So
we just use annotations to say which are.
We are currently, all of our experimentations are outside of quasi-quotes because it's just faster to do experiments. I think once we solve those problems, then quasi-quotes are
okay.
Can be adapted.
Yeah.
So, okay. All right. Well,
Okay, great.
thank you.
So let's end this meeting. Thank you very much for participating in the discussion, and see you next month.
Thank you. Bye.
Thanks, everyone.